All right, good afternoon and welcome to today's class. Yesterday we introduced theory of logarithm and we are meant to understand that maybe in the past we have been taught logarithm and we are asked to use things like four-figure table to get the values of numbers. All right, now that type is called natural logarithm or common logarithm. Why? Because they are being expressed in base 10. Okay. Now, in a case whereby we have, or rather, when cases involving log of other bases that are not 10 are being considered, it is termed theory of logarithm. Okay, good. And that was what we really discussed yesterday. And we defined that the log of a number, let's say number n, to base x is the number to which the base, which is s, will be raised to give us the value of n properly. And that's not that thing that you're going to have as the power of that base become the log of that number n. Okay, all right. Now let's actually take few examples. As regard what we discussed yesterday. And please kindly make sure you play this video. Watch it over and over again so that it gets into you, so that when you get into today's one, it becomes very easy and easy for you to really go through. Now let's actually take some example that really strengthen our knowledge or like kind of strengthen what we introduced yesterday. Let's take these examples. They'll be kind of few but many. Let's say example one. I can say write down the value of the following. Okay, write down the values of the following. Let's say I have A says that log 16 to base 2. B says log 4, so log 32 to base 4. C says log 4 root 2, okay, to base 2. Let's look at these three for now. Probably I might consider other ones as time goes on. Now, write down the values of the following. You have log 16 to base 2. What will it be? Log 32 to base 4 is what? Log 4 root 2 to base 2 is what? That's what we meant by write down the value of the following. Okay? Now, let's actually go. Let's look at some things here. Solution. Now, here it says log 16 to base 2. We don't know what it is. Now I can say let log 16 to base 2 be x. Okay? The next one is I can say convert to index form. Convert this to index form. And when we do, remember what we define as logarithm. That means log 16, which is 16, becomes equal to 2 power x. That means the power to which the base will be raised, okay, to get 16 is the log of this. That means when we get the value of s, that gives us the value of log 16 to base 2. Now this continues in this way. I will equate both sides to have the same base, okay, like we did in indices. Then 2 power 4 is 16 is equal to 2 power x. When I take away the bases, I'm left with, therefore, x is equal to 4. That is that on this. Therefore, I can say log 16 to base 2 is equal to 4. All right? Very simple. The next one says log 32 to base 2. We don't know what it is. Then let's log 32 to base 2 equal to y. Same thing, you can say convert this to index form. When we do, we are going to have that 32 is equal to 2 power y. Okay? What then do? We make the bases to be the same. We make both sides to have the same base. Okay? So I already have 2 power y. So I'll just write 2 here first. Then to what power will 2 be raised to have 32? Power 5. So when I cancel the bases, I have that y is equal to 5. It simply means that log 32 to base 2 is equal to 5. Are we following? Then the third one says log 4 root 2 to base 2, okay, is equal to what? What we don't know. Is that okay? Now let's continue. I will say let's log 4 root 2 to base 2 equal to m. Okay, then I can say convert to index form. Is that okay? Now, when I do, I'm going to have something here. Just watch me closely. This very number here, this thing here you're saying is in sort form. But let's go gradually, okay? Now, when you come out to index form, you're going to have 2 power m to be equal to 4 root 2. Is that okay? Now, according to, what is it called? Surd. Rules of surd. Rules of surd say that 4 root 2, same thing as saying 16 times 2. Okay? 16 times 2. In the sense that these two are inside square root now. Square root of 16 is 4. That is 4 outside. Then 2 remains inside. Is that okay? So this is same thing as saying square root of 32. It means that 2 power m is equal to square root of 32. Okay? At this point, what do? I need to remove this sign here. I need to remove this square root sign from this place. It has to go. How do I remove it? I will square both sides. Square both sides. And when we do, we're going to have 2 power m, all right, all squared is equal to square root of 32 all squared. According to law of indices, this is power of a power. So 2 times m is 2m. I'm going to have 2 power 2m is equal to, now this thing still means 32 power half. This sign here still means 32 power half. So I'm going to have 32 power half times another 2, which is this 2 here. Okay? So when these 2 cancel this one, that means I'm left with 1. So 32 power 1 is still 32. Okay? So we continue. 2 power 2m is equal to 32. So let's equate this here and here to have the same base. Okay, now we're going to have 2 power 2m is equal to 2 power 5. This is 32. Okay, good. So we cancel out the bases. Then we have that 2m is equal to, that means we now have to equate the powers. Okay, now to get my m here now, I will divide both sides by 2, which is the 2 is the coefficient of that unknown, which is m. M is the unknown, 2 is its coefficient. So to get the value of m, I'll divide both sides by this 2. Okay, therefore 2m over 2 is equal to 5 over 2. 2 divided 2, that is 1. 1 times m is m. That means I have 5 over 2. All right. Therefore, log 4 root 2 base 2 is equal to 5 over 2, or 2.5. Is that okay? Thank you very, very much. And I still want to go back and play this video over and over again so that you actually get used to it. All right, bye for now.